Firstly, have a nice day, everyone. My name is Yusuf. I'm gonna tell you our project. Name is Design of Indoor Robot Prototype guided by RFID-based positioning and navigation system. The presentation consists of 4 main titles. These are Introduction, Methodology, System Improvements, and Conclusions. Introduction. Since the first day of existence, human beings are constantly in search of both surviving and living life more easily. Consequently, it designs and develops tools to be used for various purposes. With these searches that lasted for ages, technology has developed and continues to develop. As a result of this development, human beings are now developing autonomous robots that do not use human power. These robots save both power and time. In today's modern cities, the number of multi-story and complex buildings increasing day by day. The fact that the buildings are large, complex, and crowded brings with it many new problems waiting to be solved. In emergencies that may occur, the need to intervene with the disaster victims in the buildings as soon as possible is the foremost of these problems. Apart from this, processes such as indoor navigation, indoor security, and organization of indoor services are some other areas waiting to be studied. Such applications require network analysis such as shortest path, shortest loop, and point to the development of integrated systems, including sensor-based communication, control, and navigation services. People are prohibited from entering buildings that are in danger of collapse due to disasters such as earthquakes, floods, and fires. However, in these buildings, valuable items and even living things such as babies and pets can be forgotten in the building. The aim of this study is to develop an autonomy or semi-autonomy prototype and a preliminary study for a robot design that can be sent inside the building and transport the things that need to be transported outside of the buildings in cases like the above. The other part is methodology. There is a list of sensors and modules which are used: Arduino Uno, RFID reader module, Wi-Fi module, gyro module, wheel speed sensor, ultrasonic distance sensor, battery charger module. And you can see our vehicle from different angles. However, the sensors and modules we use are shown. In addition, we place the Arduino Uno between 2 plates. RFID reader module. The ID numbers of the RFID cards are read. It has been used for the study, the details of which are given in the next section on RFID-based location determination. The gyro module is considered necessary to calculate the rotation angles. It has been added to the prototype to minimize the error in angular turn by using it with the speed sensor. The wheel speed sensor is available on the AlphaBot kit. It prevents situations such as decrease or increase in wheel rotation speed depending on the charge rate of the battery. It offers the possibility to determine the speed using software. In addition, it allows the wheels to rotate independently of each other. The Wi-Fi module is used to transfer the routing instructions sent from the server to the Arduino. Ultrasonic distance sensor is used to prevent the prototype from going through the middle of the path and hitting the obstacles that may come in front of during the movement. Battery charger module. Prototype has 2 batteries connected in series for power supply with 7.4 volt input voltages. The cable that will connect the B3 Pro compact charger were soldered to the battery compartments where the battery was inserted to facilitate the charging process of the batteries. Creation of the test area and installation of the RFID-based positioning system. This figure shows us test area. The test area is divided into square areas. RFID cards for the positioning system are placed on the cardboard plate. RFID cards representing square areas at the midpoint of the square areas. The yellow line shows the paths the prototype can move. There are 2 different target points. Also, RFID cards are located at these target points. When the prototype reaches its destination, it reads the RFID card plates in the square area and sends the ID number of this card to the server. When this information reaches the server, the user is presented with the target point reached information. The prototype waits at this point until a new target is determined by the user. Detection the position of the robot. While moving on the prototype platform, it passes over the RFID cards on the road. The RFID reader placed under the robot reads the number of cards during this passes. The location of each RFID card in the working area is recorded on the server. The square areas in which the prototype needs new rotation commands are considered. No RFID cards is inserted for square that are direct passage and do not have any return status. Therefore, the read ID number means that the prototype is within a square areas that needs to be rotated. According to this information, the routing of the mentioned prototype is carried out given details in the next stage of the study. If the current location contains alternative terms, the prototype will wait at this location until the redirect command comes from the server Wi-Fi protocol. The response time from the server may take a few seconds. According to the sequential routing commands sent from the server, the prototype moves until it reaches the targets. The ID numbers of the RFID cards placed in the square areas determined as the target were labeled differently from the others and recorded as target points. After the stage of determining the location of the robot, this stage of directing robot to the target comes. At this stage, first, the starting and destination points of the robot must be determined. The starting point is accepted as the current position of the robot. The destination will be one of the destinations to be selected by the user. After these two critical points are determined, the software determines the shortest path between the 2 points, that is the movement route. Routing instructions are sent to the prototype and the Wi-Fi module according to the movement route determined by the server. When a new RFID card is read by the RFID reader on the prototype, the ID number information is also transmitted from the prototype to the server. On the server side, the location information matching the incoming ID numbers is checked. If the target point was not reached, the instruction to move to next square is transmitted to the prototype. System improvements. In addition to that, with the LM393 speed sensor, it's possible to calculate the distance traveled by the wheels. And when they examine the figure, we see the Arduino Uno board. However, there are speed sensors and encoder disks connected to both wheels. Rotation angle calculation using speed sensor. For this process, first, LM393 speed sensor and encoder disks were connected to each motor. The wheel and encoder disks are connected to the same shaft, so the speed of both will be equal. In other words, it was sufficient for us to measure the speed of the encoder disk to find the speed of the wheel. As it is now, there are gaps on the encoder disk. These gaps are counted by the speed sensor as the shaft rotates, and thus the speed information is reached. At the same time, the distance traveled can be measured thanks to the speed information and the known radius of the wheel. By applying this process to the other wheel, angle information can obtain. After the angle information is reached, the wheel in the direction of rotation must remain stationary and the wheel on the opposite side must rotate for the vehicle to turn. The distance traveled by the wheel that will move here is determined depending on the angle value. Conclusions. In this study, subject of design of robot prototype for indoors created by RFID-based positioning and navigation system is examined. Within the scope of the study, a prototype robot was made. It was carried out determining the current position of the robot with a positioning system and to send it to the target determined by the user autonomously on cardboard platform. In this context, with the developed software and modules, the robot was tested in the test area and it was observed that it reached the target. It is foreseen that better results can be obtained in future studies if the problems encountered during the determination of rotation angles can be eliminated by using different methods and sensors. If you have any questions, please ask from these email addresses. Thank you for listening and thank you for your patience.